Thank you for joining us on another lesson. This one, the topic on graphing equations from a table. So one of the earlier videos in our long year here, our semester, for some of you, year for others. And this is an important skill, and I'm hoping that although I have 5 examples in just the first part for you here, if you stick with it, you might be able to pick up on some really helpful hints. And so we're going to start really small. One of the base and easiest functions, y equals x. You might even know what that picture looks like already, but if you stick with us, we're going to go through a couple examples, and you might be able to figure out how you can graph these a whole lot quicker, especially a rough sketch. So what we're trying to do is we're trying to use a table to help graph this. We want to make as few points as possible, but we want to know for certain what this graph looks like. And you'll learn this in a little bit, but in this function, x is my input, which means I put in values for x. Easiest one always to try is, what if we let x be 0? Well, in a function like this, if I let x equals 0, that would mean y equals 0. Because if y equals x and x is 0, then y is 0. You can fill that in our table, and so I think already you've caught on. Whatever x is, y is. If x is 1, y is 1. X being 2, so would y. Even if x is 3, y would be 3. What about negatives? Well, if x is negative 1, y is also negative 1. And we'll do one more. If x is negative 2, y would also be negative 2. So we won't graph this many points every time, but just to get the hang about it and what we're doing, let's go ahead and plot these points. Now, we broke out the graph paper just for this. 0, 0, right on the origin. 1, 1, that means I'm going to go 1 in the x direction, 1 in the y direction, plot my point. 2, 2, 2 in the x, 2 in the y, plot my point. 3, 3, 3 in the x, 3 in the y. You can already start to see I've got that diagonal line going right through my origin, which hopefully some of you already knew. When y equals x, that means whatever x is, that's what y is, and it creates that diagonal line right through the origin. That if I actually ended up turning my paper on a diagonal, it would create a straight line up and down. And so let's finish graphing these negative points. Negative 1 means I go to the left 1, down 1, and negative 2 to the left 2, down 2. You get that. And if I'm going to use a ruler, you better use a ruler. Let's go ahead and graph that line right through those 6 points, and like I said, that creates that diagonal line right through the origin. Y equals x. This is known as the parent function of a lot of linear equations, this being the main one. So let's use that. I'm going to just put this off to the side because we might refer back to that. Looking at this second question here, y equals x minus 1. Now think about this. Same exact thing as before, y equals x. All I'm going to do from all my x values that I put in, all my input values, the output would be decreased by 1. That might not make sense right now, but let's see what happens. So if I plug a 0 in, again, the work for this, and I'll do it, but I'll always talk through it in my head. I won't always show it. Y equals 0 minus 1. Well, 0 minus 1 is a negative 1, which means when x is 0, y is negative 1. When x is 1, y is 0. That's because 1 minus 1 is 0. And then let's jump 2 this time. Let's go right to 3. If I plug a 3 in, 3 minus 1, 3 minus 1 is 2. Now let's try some negative values, because again, I want to try as few amount as possible, but I do want to have a good picture. And so if I just do that, and let's graph these a while. 0, negative 1, 1, 0, and 3, 2. It looks like a good picture. I don't know for sure what it looks like. So let's do these 2 negative values. Let's see if when I go negative, it does indeed keep going down. That would tell me I definitely have the right picture. So let's try negative 1. If I put a negative 1 in, here's one I'll show work for. Y equals negative 1 minus 1. Well, negative 1 minus 1 means I'm getting even smaller. That's a -2. So when y is -1, I'm sorry, when x is -1, y is -2. And let's do one more. When x is -2, -2 minus 1 gives me a -3. So -2, -3. And I do indeed have, oh, I'm sorry, I also want to graph -1, -2. But I do indeed have that straight line not going through the origin this time. So again, let's look at the first thing that happened here. My first graph went right through the origin, y equals x. My second graph, y equals x minus 1, all I did was take the same graph and I dropped it down one value. Keep that in mind as we move forward. Alright, third one. I'm not going to minus anything, I'm not going to plus anything. I'm going to multiply all of my inputs by something. So keep track about my line. My first line went right through the origin like this. You think my line's going to get steeper or more shallow, almost to a horizontal line? We'll have to see. Let's start with 0 again. 0 is always an easy one to pick. 0 I don't even need to show work for, because you know anything multiplied by 0 is 0. If I plug a 1 in for x, here's the work. This is what I'm going to be talking you through. Instead of an x, that x is now a 1. And 3 times 1, well, 3 times 1 is just 3. And so that means when x is 1, y is 3. Let's go to 3. When x is 3, y is 9, because 3 times 3 is 9. Let's try some of those negative values that I was talking about. We want a complete picture. So let's try -1. -1 times a +3 is a -3. And let's try -2. -2 times 3 is a -6. So I have a couple of negative points I got to plug in, and I've got a couple of positive points I'm going to have to plot. Let's see what happens when I graph these 5 points. 0, 0, easy point to graph, right on the origin. 1, 3, that means I go to the right one, +3. 3, 9, to the right 3, but I got to go up 3, 4, 5, 6, 7, 8. I got to go up 9. You can already see that's the highest point we've plotted so far today in this video. So you might be starting to figure out how this line looks. -1, -3. And then -2, -6. And if I get my ruler out, and I don't think I need to for you guys to understand this picture, this is a whole lot more steep of a line. Again, let's grab that original graph. That original graph, y equals x, went right through the origin. See how it's a little bit more out? It's pointing out towards the top of my picture. If I quickly replace that with y equals 3x, look at that one. A whole lot more steep. It's more so pointing up than out like the last one was. So keep in mind, see what happened there. I multiplied my inputs by some value. We've got 2 more on this video. This is part 1 of graphing from a table. Then we're going to get them to be a little bit more difficult for part 2. But as you see here, I am, even though it's a fraction, I'm multiplying by something. I'm multiplying by a number less than 1. So right away, again, we've done this before. This is a common theme with these videos. If you want to pause this and graph this on your own, I think you should get the hang of this. I'm multiplying by a number less than 1. I'm thinking instead of that graph that originally went through the origin and got steeper with number 3, I'm thinking by multiplying it by less than 1, I'm going to take that and it's probably going to get more shallow, approaching that horizontal line type graph. So let's plug in 0. 0 is always a good number to choose because anything times 0 is 0. So let's go ahead and plot 0, 0. That's an easy one. If I try a 1, 1/2 times 1, well, that's 1/2, and that's going to be hard to graph. We can do it, but it's not as accurate because you saw how I had to make that graph so much smaller, or that point so much smaller than that point. That's because I was running out of room with this marker. So let's think about what values would be good to choose. I'm taking half of a number. If I take half of an odd number, it doesn't really be the best number. Not when I'm talking about graphing. So let's take half of an even number. Because if I plug in 4 for x, half of 4 is 2. That's an easier picture to graph. 4, 2, a lot easier. Let's try some negative even numbers. So negative 2. Well, what's half of positive 2? Half of a positive 2 is 1, so half of a negative 2 would be negative 1. And let's try negative 4. Half of negative 4 would be negative 2. And just like we thought, when I draw this line, I multiplied this original function, that parent function of y equals x, I multiplied it by half. And you can see that original one went through the origin kind of like this, a whole lot more up and out. This one, a lot more out. It's a little bit more narrow, not as steep. And so when you start to see this, keep in mind, I think you're catching on what happens. So let's see if you really know what happens. Last one from the first video today. Graphing equations from a table. Y equals 2x minus 2. So, I still have the y and the x from my parent function, my original parent function that put that graph right through the origin. But this time I'm subtracting 2. So that graph that's going through the origin, now it's going to be dropped down 2 places. So it's going to look like that. And I'm multiplying all my inputs by 2. So through the origin, dropping down 2, getting steeper. So I'm thinking I might have a line similar to that. If you want to pause the video right now and do this on your own and check it out, I think that would be a good idea. If not, we're going to continue together. So definitely start with 0. I need to plug in a good amount of points to get a good view. I'm also going to show work for maybe a couple of these because it's a little bit harder to do in your head, especially if these numbers were a little bit trickier than 0, that's for sure as well. Anything times 0 is 0, and then I would have to subtract 2 from that. So that means y is equal to a negative 2 when I plug in 0 for x. So x is 0, y negative 2. Let's try 1. When I plug a 1 in for x, 2 times 1 is 2. 2 minus 2, 0. And let's try 4. If I plug a 4 in for x, 4 times 2 is 8. 8 minus 2 is 6. So that's 0, negative 2. 1, 0. 4, 6. So you can start to see there's my diagonal line. Let's just try a couple negative, because when you get to that next video, guys, trying the negatives is going to be super important. It might not always be a diagonal line. So let's just do 2 easy ones. Negative 1, negative 2. So if I plug a negative 1 in here, 2 times a negative 1 is a negative 2. Negative 2 minus 2. So this might be one we want to keep track of. So let's try that again. Y equals 2 times a negative 1. Then I want to subtract 2. 2 times negative 1, negative 2. Minus 2 means y is equal to a negative 4. So, negative 1 for x yields a negative 4 for y. Negative 2 plugged in for x. Negative 2 times 2 is a negative 4. Negative 4 minus 2 is a negative 6. So we have negative 1, negative 4, and negative 2, negative 6. Let's get that ruler back out. You do the same, and when I draw a line through those points, it's exactly what we were talking about before we started. Original line went through the origin, but then I subtracted 2, and then I multiplied by 2, and I got it a whole lot steeper. And so that gave me a nice picture that looks like y equals 2x minus 2. I know it was a little long, and you might have thought it was easy. So go ahead and tune into our next video, which is still going to be graphing from a table, but the functions won't be linear.